Welcome back to Wickerson Studios. Michael Wickerson here, and I am continuing with the GH Basics, looking at the curve menu of Rhino, and we have moved from the first script of basic curves dealing with single points, multiple points through to divided curve number of segments. And we're going to take a look at point cloud. And before adding and removing points, we're just going to basically look at Grasshopper as to how you would use or create a point cloud. And then I'm going to create a pretty interesting geometry from that. So to entice you, basically, jump over here to this table design. You'll realize once you get to the playground, I've got the ability of custom changing the height of this. I've got the ability of basically controlling the ellipse as to what I want as a tabletop. I can add and subtract that to the actual addition of raising and lowering that, and I think there's a few other node sizes if you wanted to change, and you can change the end caps to whatever you want as well on the subdivision. Pretty interesting geometry, pretty simple to start. Now the other thing that's interesting is you can come in here and use a gene pool that will allow you to change the legs of this and custom design the legs as to where you'd want it to go. A pretty interesting bent pipe tabletop plywood design, and computational design is exactly that, pretty darn interesting. So I'm just going to leave that as a little bit of a sketch, and I'll show how we actually made it. These files are all shared, and basically go into curve, point cloud, come across, and we'll be adding points and removing points later. But that's exactly what I did here. Went into curve, went into point cloud. We're going to get busy with creating points, and I'm going to make sure we take on all the geometries here and turn it to preview on. You can see that there's an awful lot. I'll take this off so we're only seeing what we're clicking. 3 point clouds you can create. This one's fairly simple. It's along the base of the structure, and I'll put this one back to shaded. You can see that it generates a point cloud from a rectangle with a certain amount of points across a certain range. A domain, sorry, I should say. And you can put in as many points as you want from that. So the more you put in, the more complex your object's going to be. I have it set, so I have to be careful how I'm indicating this. Put in more points or less points. So I think 8 was pretty good. The populating 3D, if you think about it, is actually coming from a box form. And the populate geometry is similar. I chose a sphere at this time because populating geometry, 3D geometry, is only surface points, whereas the populate 3D here versus populate geometry is it will find its way into the volume of the surface. So in taking these points, I copied those points here and I put them through a very similar 0 to 2 pi rotation. And in doing so, I'm able to kind of play with those and create additional points, which I then drove from these points here to these points here, populated, and what would I do with it. So I played around a little bit with the points, twisting, and doing similar to what I did before. Now if you take a look at this, you've got red for your parameters, yellow for your Rhino commands, green for your geometries, and then blue for the sandbox. What I did was I went back to these initial points here, and what I wanted to do was use a type of control of sorting. And that's additional. We'll get to it later on, but basically deconstruct your points and sort according to the X and sort according to the Y. And what happens when you interpolate those points, you'll get a curve that looks like this and a curve that looks like this. And of course that will change drastically depending on the amount of points that you choose to populate with. So if I come back here and start to populate like this, you get these more interesting interpolated curved line points, this one and this one. Then if I reverse that, which I didn't have to, but I reversed the actual curves so I could interpret the points here and here, and I had a loft to this curve. So I have the original curve down below and I lofted the other one above. So if we click on here, you'll see that you have your two curves. You're then taking your points on each one, you're drawing a line between them, and that's basically the geometry that I put the subdivision and piped the other curves. And then with the surface, this was nice. I had my points and I thought, well, let's just use the arithmetic mean as the input of the points, and that will predict the center point of those points. A really nice tool, arithmetic mean. And then build an ellipse over that, surface it, and extrude it. a very simple form. I'll have it on GitHub. But if you're getting into computational design and you find this interesting and you want to keep things elegant and simple, it's a nice little script. It shows the learning of Rhino curve, basically point cloud, creating point clouds, a few examples of how to create point clouds, and then I'm utilizing those point clouds, just this one at the top, to pull out points that I can start to, once again, deconstruct the points to gain data, to sort, to interpolate, and then loft, and see what ends up happening. So pretty easy stuff. Nice subdivision tools, pipe, you could use variable pipe, and aesthetically you can really kind of just take a look at this and see what you like. So what I'm going to do is I'm going to go back, grab everything but those final nodes, take preview off, put this so you see everything, and then select the one that I have. Nice little diagram, nice little shape. If you want to get into piping, it can be kind of fun. I'm going to grab the other pipes as well, and that's it. Not too hard to figure out. Render, and back into all of our sides, zoom extends all, and you could easily get into computational design, find yourself work for custom fabrication, get into your own design builds, and the power of Grasshopper is endless. Thanks very much for watching.